In this video, I'm going to talk about roaming between centralized controllers. As a wireless network grows, one controller might not suffice. When two or more controllers support the APs in an enterprise, the APs can be distributed across them. As always, when clients become mobile, they roam from one AP to another, except they could also be roaming from one controller to another, depending on how neighboring APs are assigned to the controllers. As a network grows, AP roaming can scale too by organizing controllers into mobility groups. The following sections in this video discover intercontroller roaming, mobility groups, and the mechanisms used to coordinate roaming. First, let me to explain about the layer 2 roaming. When a client roams from one AP to another and those APs lies on two different controllers, the client makes an intercontroller roam. This figure, the left figure actually, shows a simple scenario prior to a roam. Controller WLC1 has one association in its database. As you can see here, this is the wireless LAN controller 1 and AP1 associated with this wireless LAN controller, and here you can see the table of association of wireless LAN controller 1. AP is AP1, association is client 1, and WLAN, or for example the BSS that this AP provide has the WLAN of SSID of staff, and the VLAN number is 100 SSID staff, and the VLAN number is 100. And as you can see, this is the result of a client roaming to AP2 in the right figure. Here, as you can see, the client moves to the BSS of the AP2, and as you know, AP2 is associated with the wireless LAN controller 2. This is the table of the wireless LAN controller 2. AP is AP2, client is client 1, and WLAN is staff, and VLAN is 100. The roam itself is fairly straightforward. When the client decides to roam and reassociate itself with AP2, it actually moves from one controller to another, and the two controllers must coordinate the move. One subtle detail involves the client's IP address. Before the roam, client 1, as you can see here, is associated with AP1 and takes an IP address from the VLAN and subnet that are configured on the WLAN supplied by controller WLC1. In the left figure, in this figure, WLAN staff is bound to VLAN 100, so the client uses an address from the 192.168.100.0/24 subnet. When the client moves or roams to a different AP, it can try to continue using its existing IP address or work with the DHCP server to either renew or request an address. This figure, the right figure, shows the client roaming to AP2, where WLAN staff is also bound to the same VLAN 100 and 192.168.100.0/24 subnet. Because the client has roamed between APs but stayed on the same VLAN and subnet, it has made a layer 2 intercontroller roam. Layer 2 roams, commonly called local to local roams, are nice for two reasons. First, the client can keep its same IP address, and second, the roam is fast, usually less than 20 milliseconds. Alright, now let me to explain a little about the layer 3 roaming. What if a wireless network grows even more, such that the WLAN interface on each controller are assigned to different VLANs and subnets? Breaking a very large WLAN up into individual subnets seems like a good idea from a scalability viewpoint. However, when a wireless client roams from one controller to another, it could easily end up on a different subnet than it's started with. Clients will not usually be able to detect that they have changed subnets. They will be aware of the AP roam, but a little else. Only clients that aggressively contact a DHCP server after each and every roam will continue to work properly. But to make roaming seamless and efficient, time